Hey there Seahawks, it's Miss Adams, and in this video we're going to do some real world functions, and we're going to also take a look at the closure properties. Alright, so a set is closed for a specific operation if and only if the operation on two elements of that same set always produce an element of that same set. So our first example, we have the numbers 0, 1, 2, 3, 4, and so on. So all of our whole numbers are 0 and bigger, and they're increasing by ones. So if I add a whole number, like let's say I take 1 and I add 5, I'm going to get 6, which is also a whole number. Any whole numbers that I add together, I'm always going to get a whole number. So it is closed under addition. If I subtract, let's say I take 4 and I subtract 8, that's not going to give me a whole number. That's going to give me a negative. And negatives don't fall under those whole number categories. So that is not closed for subtraction. Multiplication, if I do 3 times 7, I get 21, which is a whole number. Any two whole numbers that I multiply together, I will get a whole number. Okay. Division, if I did 4 divided by 3, I get a fraction or a decimal, and that is not a whole number. So whole numbers, 0 through whatever, infinity, counting by ones, so positive integers including 0, are closed under addition and multiplication. Now this next one is negative integers. So just the negatives, not positives, not 0. So if I do a negative plus a negative, I'm going to get a negative number. So it is closed under addition. If I subtract, let's say I do -2 minus -3, well, the minus and negative turns into plus, and that would turn into a +1, so it is not closed under subtraction. If I multiply a negative times a negative, I'm going to get a positive, so that is not closed under multiplication. And if I divide, a negative divided by a negative would give me a positive. So this one, the negative integers, just the negatives, are only closed under addition. Now, this next set is all integers. So from negative infinity to positive infinity, including 0, but only counting by ones, increments of 1, are going to be closed under addition, subtraction, and multiplication. Okay, pretty much you're never going to have anything that's closed under division. Okay. Rational numbers, which can be integers, they can be fractions, they can be decimals. They just have to be non-terminating, like non-repeating, non-terminating numbers are irrational. So they can't be irrational numbers. But as long as they have an end or they have a pattern, then they're okay, even if they're decimals. Okay? Those would be closed under addition, subtraction, and multiplication. And polynomials are also going to be closed under addition, subtraction, and multiplication. Polynomials are what you've been working with that we've been calling functions. So a polynomial is made up of terms. It has a leading term, which is whichever one is to the highest degree. And it has constants. It doesn't necessarily have to have all of those. Okay? And it has to have whole number exponents. So polynomials cannot have fractional exponents. And there's not allowed to be any variables in the denominator for it to be a polynomial. Right? The freshman class is selling t-shirts to raise money for a field trip. The cost of each custom designed t-shirt is $8. There is a $45 fee to create the design. The class plans to sell the shirts for $12. Define the variable. So the thing that's going to be changing is the number of shirts that they sell. So we're going to say, let T represent the number of shirts sold. So then it asks us to write a cost function, a revenue function, and a profit function. So cost is how much is it going to cost the freshman class to get these shirts created. Revenue is how much money are they going to get? Are they going to collect? Okay, so how much money will they actually have when they've sold it? So how much money will they have in their hands from collecting money from students? And then profit is how much did they actually make. Okay, so when you take out the cost, how much did it cost them to get them made? And then the revenue, what they have left, is the profit. All right, so the cost function would be the $45 fee to get them created plus the $8 per t-shirt. So $8 per the number of t-shirts sold. The revenue function, well, they're selling them for $12. So revenue, that should be a T. Oops. Revenue of T would be 12 times T. Okay, and then the profit function would be whatever your revenue is minus the cost that it costs to make all of those. So my revenue function was 12T minus my cost function, which was 45 plus 8T. And I'm subtracting, I have to distribute that negative. So I have 12T minus 45 minus 8T. I could combine like terms, so 12T minus 8T gives me 4T minus 45. So that's my profit function. All right, now this is composition of functions, and I don't think you're going to see it too much on FSA, but I want to go over it briefly just in case you do. So f of x equals 2x and g of x equals x minus 4. This says find f of g of x. Okay, so what that means is g of x is inside of f of x. So you're going to take your g of x function and you're going to plug it in where x is in your f of x function. Okay, so f of g of x is equal to, well, f of x is 2 times x, but I'm replacing the x with x minus 4. So it's going to be 2 times x minus 4. Then I would distribute the 2, so that would give me 2x minus 8, and that would be my solution. All right, f of x equals 2x plus 3, and g of x equals x minus 3. Find g of f of x. Okay, so notice they were written a little differently, but they're the same thing. So this could be like g with that little circle and then f. So g o f of x, or it could be written this way. Okay, but notice the f of x is inside the g of x. So the g of x is going to be eating the f of x. Wherever the x is for g of x, it's going to be replaced with whatever f of x is. Okay, so it's going to be g of f of x equals 2x plus 3 minus 3. The plus 3 and the minus 3 cancel out, so that leaves me with just 2x. All right, that's all.